Hello, hello, hello. Good morning, good evening, wherever you are. My name is Mark Borstein. I am the CTO at Tremolo Security and the co-author of Kubernetes and Enterprise Guide 3rd edition. Scott, my co-author, is running a little bit late. Apparently he has a day job that requires him to actually work. He's going to be running a little late today, but he does believe he'll be able to join us. So looking forward to him joining. So we are staying in chapter 9 this week. Last week, we started with vClusters and we got introduced to what a vCluster was, what a virtual cluster was, the problem it was trying to solve around multi-tenancy. This week, we are going to get a little bit deeper. So topics we covered last week: one, just getting a vCluster up and running. Two, is kind of what those pods look like, how a vCluster, how the vCluster works to rewrite pod definitions inside of the host cluster, so that your pod knows to talk to the virtual cluster API server. And finally, we got into how you do enterprise authentication with a vCluster, because once you've got a vCluster, you've got to get users into it. So we walk through how that would work. This week, we're going to dive into the middle section of this chapter. This chapter has a lot of labs in it, and we want to make sure to take our time. So we're breaking it up over a few weeks. So this week, what we're going to do is we are going to do a couple of topics that are kind of setups for the finale of this chapter. One of the things that I think makes our book different from other books is that we want to tie things together, right? Like we don't want to talk about something in isolation and then that's it. We never come back to it. So far in the book, we've talked about networking, we've talked about authentication, we've talked about RBAC, we've talked about secrets management, we've talked about vCluster. So by the end of this chapter, we're going to have a automated platform for deploying our virtual clusters. Those virtual clusters are going to be highly available and integrated into Vault for secrets management. So in order to pull that off, we got to know how all those things kind of talk to each other. So that's what we're going to be doing today. And so last time when we finished, we had a vCluster deployed into a host cluster with an open unison in each to do the authentication. Next, we're going to look at how vClusters interact with external services, because there are a couple of gotchas that we've run into. So if you've got the book set up and are following along, we're going to start on page 280, end of page 285, accessing external services from a vCluster. If you're watching at home, please do feel free to say hello. We love comments. We love saying hi to folks. I do want to send out a quick apology to all of our friends on LinkedIn. There was a link at the end of our post for referrals to use StreamYard. I got very, very angry when I noticed that, because I'm not asking any of you to use StreamYard for anything. We use it for now, but I will say that I did not realize that they were inserting that link in there. I will remove it and be more careful in the future. I do apologize. So that said, let's have some fun. So if you watch chapter 8, it was chapter 8, yeah, where we started with Vault. And in that chapter, we wanted to make sure to use our pod's identity to communicate with Vault. So that way there were no static secrets, right? Vault would take our pod's identity and validate it and make sure that was still running. And so that becomes really important here in when we talk about automating vClusters, because vClusters need to be automated. Like we did it manually, but you don't really want to do it manually. Nobody's going to really be happy with that. And this is Kubernetes. We should be automating everything, right? So let's go ahead and get started. So if we take a look Go ahead and share this. So we'll come back to this real quick. Here we go. So hide this because you don't need to see that. And I'm going to export PS1 equals that. All right. So I've got a pod here running inside of my tenant, right? So I've got the pod, it's running inside of my tenant, and but I'm right now in my host cluster. Okay. So this is the pod that's actually running inside the host cluster. And if we take a look at our annotations, what we're going to see here, oops, is that there are a bunch of annotations here that are used by the syncer to set up the proper setup in the host environment. So we'll see we've got pod IP, we've got labels, we've got the kind, all this information. This is all used by the syncer to properly set up the pod inside of the host cluster. Because going back and review, a virtual cluster is really just an API server and a syncer. The nodes themselves, or the pods themselves, the workloads themselves, run in your host cluster. They don't run inside of your virtual cluster. The pod is kind of tricked into going to talk to the virtual cluster as its API server. But all the scheduling and all that actually happens on your host cluster. And so there's an interesting side effect of that, is that means a lot of the information has to come with it for the admission controller. And one of those things that comes with it by default is the token. So if we see here, we have a token. Right? That token is stored as an annotation on the pod. This is your token. This is the token from your pod, right? So we've got this pod running. So if I do a kube control exec ti tenant one, right? So I'm exec in var run Kubernetes var run secrets. There we go. Token, right? This token and this token are the same. Hey, there's Scott. All right, let's go ahead and.
Thank you.
Hey,
Thank you, Mark.
Scott.
Apologies for crashing everything right now.
Ah, no, no worries, no worries. Apparently, you have a day job that requires you to
Apparently,
work.
yes. Which actually pays the bills, yes.
What's the half for? Is that Boston University or Buffalo?
It is Boston University. That's where I went my master's degree.
Oh, really? I didn't know that.
Yeah, it's BU hockey. I did not play for him. I wish I
Um,
did, and was nowhere near as good to play hockey.
So my fun interaction with BU was that they had a wrestling camp there every summer, and they would use the mats for my high school team. And so we got free scholarships to go every year. So every summer in high school, so 3 summers, um, I got to go for free to BU's wrestling camp. Um, so that was a lot of fun. It was a lot of fun hanging out at BU. That it's got a
Big
great little
campus.
campus there.
Big campus. Good on sports, man. There's no doubt. They got a great hockey
Yeah.
team.
Um, so yeah, so we're just starting to dive into talking about how once your V cluster is deployed, you still want it to talk to enterprise services as if it's a normal Kubernetes cluster, right? So we're talking about how by default vCluster will put its service account token as a annotation on the pod that gets synchronized into the host cluster.
Mhm.
And so what I had just shown here is this is the annotation from our pod. It's the same thing here, right? These two values, if you look at them, are the exact same. And the way that it does that is if we look at the pod itself, so kube control, get pod, oh, I'm actually logged in. So if we do OYAML into less, because less is more. So there's that annotation. Now we come down to where the actual projection is, and we have a volume mount. So instead of it being a projected token from the standpoint of like the host API server projects the token, it actually configures. Let's see if I can find that's the owner reference, containers, and looking for the security section. So like here's the API access. So here, it's actually projecting the token from the annotation into the pod, which is actually, before I saw this, I didn't even know you could do. And if you've got if you've got a dev pod, dev cluster that you're just like, I'm firing this up real quick, not a big deal, right? Like, I'm firing it up, it works, shut down, whatever. But if you're in production, this can be a problem, right? I mean, don't y'all log whenever you create a pod?
Well, it should be, right? It's coming from the API server, so kind of heard not to log.
Yeah, so like, and quite frankly, somebody's debugging. Um, there's a lot of times that your logging alone can get you into trouble with this, because now if you log this, like admission controllers will often log, hey, this is the JSON I got, right? You've now leaked a token.
So I got to make
So
sure you're going back to our auditing we did
yeah,
before previously,
exactly.
that depending on how you set up your config, you want to be careful. Don't just say log everything, because yeah, you get this and you don't necessarily want that.
Exactly. So storing the token as an annotation, not a good idea. At least not for production. There's another aspect of this that's really important. So let's go ahead and take a look at this token again. So here's the token. I'm going to go ahead and grab it and drop it into everybody's favorite tool, jwt.io. Now we can see that, yeah. So here's when it was initiated. It was initiated on Wednesday, April 23rd, 2025, 10:31 a.m. GMT. It expires on Saturday, April 21st, 2035. That
There's
is
a
a
new definition to long-lived
10-year.
token.
Yeah, I mean that might as well just be like forever token, right? Like that's it at that point. So this might as well be a token without an expiration for all intents and purposes, with a very important caveat, in that if your external system is doing a subject access review, right, actually asking the API server, is this still valid? Then, and that pod has died, your API server won't accept it anymore. But if you're just doing a straight up JSON JWT check, like any other OAuth 2 token, this is a problem, right? Like so when you're working with an external system, you want to make sure that your vault, or with vClusters, that you're in fact using your something that's going to do a subject access review, not just something that's doing a JWT check, because these tokens are good forever. And there's no kind of a CRL, right? So, and this will look exactly like every other token, because it is a projected token, right? It is a token from an API server, right? In this case, K3s. But you can't, a 10-year token, and it's a known issue, and there's an open issue of vCluster. I'm hoping at some point in the not too distant future, they'll figure out a way to address it. So there are two issues that we need to find a way around here. First off is the way that the token gets projected, and then secondly, the way that the length of time that the token is allowed to the token is allowed to run. So when it comes to the amount of time, that's why we were talking about subject access reviews, right? And we saw that in Chapter 8 how that worked, and at the end of this lab, not today but next week, we'll show how that would work with vClusters. So the next question is, how do we get around this thing where it's embedding the token inside of our pod spec? Because we don't want that. So there is a pretty easy way to do this, where instead of using the pod spec, a secret gets created, and that secret in the host cluster, and that secret gets mounted and projected. Inside of our YAML, so let's see here, it's going to be in vCluster value secrets. Where am I? Over here. PWD. So I want to be in. Am I in the right one? No. I think I want to be in host. Yes, vCluster value secrets. So vCluster secrets. All right. So this is what we're going to upgrade our cluster to. And this configuration, the main difference here is we're going to tell our vCluster, hey, use secrets for your service account tokens. And so that'll get us around having to actually do having to have the service account tokens inside of the pod spec, inside of our YAML. So I'm on page 284. And we are going to go ahead. I'm not control get nodes. Okay, so I'm in the host cluster. So I'm going to go ahead and run this command. And this is straight out of the book. All right, so when we recorded last week, vCluster 0.24 had a bug where if you upgraded a non-default Kubernetes implementation type, so in this case we're using K3s, whereas the default was vanilla K8s, the upgrade would fail. Now, I will be honest, I looked. There was somebody who had submitted a PR to fix it. Doesn't look like it got released yet. I downgraded to 23, but I haven't tested this. So we might have to do some downgrading here to find a version of vCluster where upgrading works. So let's see what happens here. And there's a newer version. That's okay. So far, so good. Awesome. Okay, so we got that. So now we've upgraded our vCluster with the new configuration thing so that we're creating SA tokens. Now, because we have pods already running, we got to kill them, right? So let's go ahead and delete all the pods. You know what? I'm going to vCluster list. All right, vCluster connect tenant one, or vCluster connect my vCluster. There's Kafka. I was wondering where you were, my friend. All right. Bonjour, bonjour. Okay, so
Sure.
tenant one, and tenant one, right? Okay, so kube control, get pods. Oh, vCluster, disconnect. Control, get pods. All right. Control, get nodes. Did I just... No, there's tenant one.
You get paused
You
though.
know
You didn't say the namespace for that.
Oh, you're right. You're right. Control. Okay, so let's try connecting vCluster again. Right, tenant one. Kube control, get pods. Okay, there we go. So I'm actually going to delete this pod. And wait for it to come back, and then we'll go back to the host cluster and see what changed.
Throw finalizer. Come on. Speed
I
that
think I
up.
can. I think I can. I think I can. Really not that much going on here. Come on, VM. There we go. All right. So I'm going to do a vCluster disconnect. Right. And then kube control get secrets and tenant one. So we now have a secret. We should have a secret. All right, let's get our pod. Make sure that kube control get pods and
See anything in tenant one? Wait, tenant spelling mark.
oh, yep. Foiled again. I don't have a pod. Interesting. Oh, McFly.
You created the pod directly, didn't you?
Yeah.
And what do we always say? Don't create pods directly.
Pods directly. Yeah. All right, let's try this one again, shall we? All right, CD, simple, kube control, F, virtual pod, kube control get pods. All right, so that's running. So Mark. All right, export PS1 gets. All right, so we'll do a vCluster disconnect, kube control get pods and tenant one. Okay, so there's our virtual pod. Kube control gets secrets and tenant one. All right, here we go. So now, instead of everything being in the annotation, we have a secret. Get secret and tenant one. Oh, YAML. All right. So now, instead of our token being in an annotation, we actually have everything stored inside of, or we have it stored here inside of this secret. So now, JSON into JQ-R dot data base64-D. So now this will be a jot that we can go ahead and drop into jwt.io. Right, so now we have our new jot. Now it still expires in 2035, right? So that, that's still sad. That still makes me sad, unfortunately. But at least now our token's not in our metadata, right? So if I clear this, let's go get an original command. Right? Yeah. No. See, so now our metadata doesn't have a token in it. So now at least if the JSON gets logged, it doesn't become a leak of a 10-year token. So if our friends at vCluster are watching at Loft, if you could find a way to rotate those tokens, that'd be awesome. But at least we have solutions to be able to handle this problem. So when we get to the point that we're going to talk to, Vault, there's really two aspects that we need to be able to handle. First off is the authentication, right? So we're saying, all right, in order to do that authentication, we're going to want to set up Vault to validate that the token is still associated with a running pod, right? Because if that pod dies, we don't want Vault to accept that token anymore because that's a 10-year token. That's basically a forever token for all intents and purposes. So that's the first part. The second part is authorization. Now, when we look at what a Vault policy will look like, you're typically going to get a J. You can write the policies based on claims in the JWT, but you can't parse values of the JWT. So if we take a look here at our claim, we'll see that we know what namespace the user is a member of, right? And so we can write a generic policy in Vault that says, hey, anybody who's a member of the default namespace can access the secrets in this section of Vault, right, in this path. And so we could, in theory, say, you know what, we're going to rewrite things so that the host container's service account gets used, or the host cluster service account gets used, not the virtual pod service account, because the it's running in that host cluster, right? Because if we do, let me rewind. I'm not doing a good job explaining this. When we did our integration with Vault in Chapter 8, we did an integration where we onboarded a cluster into Vault, gave it a token so that it could validate, it could run subject access reviews. If we would like to avoid that for virtual clusters, because that means that every virtual cluster needs to be onboarded into Vault as if it were its own cluster. In order to avoid that, we would need to either write a new policy for every single pod that gets launched, because we can't introspect the namespace in the virtual cluster from the host secret. So we would have to make it so that every cluster, virtual cluster, every namespace in the virtual cluster would have to have access to every secret for every other namespace in that virtual cluster, right? And that might be just too much. So we would, that's not really least privilege. So when we get into this later in the chapter, next week when we do this integration, we're actually going to treat each virtual cluster as a standalone cluster and integrate it directly into Vault. So we're about halfway through. There's no questions over in the chat. Scott, I've been throwing a lot at you. You have any thoughts here?
No, I just always, although I seem to be delayed a bit. Let me check all good explanations, and these are all keys. vCluster always looks so simple, but there's a lot of moving parts to it.
Oh yeah, and like anything else, making it work in production is a big difference. Is a lot different than making it work in a lab environment.
Okay.
So we've got so that's the first part of what we're going to be looking at. The second part of what we're going to be looking at is HA, right? Because you want your stuff to be highly available. So Scott put together for an earlier chapter a multi-tenant or a multi-node kind cluster. So we're going to piggyback off of that. So first thing I'm going to do, so I'm now on page 287, kind, delete cluster and cluster one.
As you're doing this, Mark, I want to just make a note on your DHA portion, right? Because I know some people I've in the past have said, well, do I really need that? And we know you do in case a pod goes down, but you upgrade your cluster, what you're going to do, right? That pod will restart. Yeah. And that's why you always want to have HA, because you don't want to have your vClusters going down when you upgrade your host cluster. So you always want to have at least, 2 replicas, if not more.
Exactly. Now I've got a backup VM over on DigitalOcean if I run into issues deploying this cluster. But you want to have HA, and when you're talking about HA with vCluster, now you're talking about data and state, right? The original vClusters that we launched were stateful sets, just using a SQLite database running locally against the Rancher local path provisioner, right? So when we did our upgrade, as an example, and it rolled out a new version of the stateful set, Kubernetes went down, right? It might have only been for a second, but it still went down, right? And in a production environment, you don't want that. You want it to be highly available. So once you start getting to a highly available, then the question becomes of data and state. Well, you can't use SQLite with a multi-attached PVC, right? Like SQLite is not a network-enabled database. It's a single in-memory database with local data. So you need to have a centralized data store. vCluster gives you a few options. If you're using vanilla K8s, which is now the default, they go with etcd. I'm not a huge fan of this approach because, to me, one of the big benefits of vCluster is simpler management. Now, if you have, I think it's vCluster Pro, they actually embed the etcd directly into the vCluster container, so you're not firing up multiple nodes and multiple containers to manage, and it makes it a lot easier. But I'll be honest, I like K3s for virtual clusters. I find that the simplicity, like as long as you don't need the breakneck performance you're going to get from vanilla K8s, the really nice thing about K3s is that you can use a relational database as your backend. And they're 2 relational databases. Well, technically 3, because SQLite is a relational database. But network enabled, you can use MySQL or Postgres. Not MariaDB. Has to be MySQL. So if that's an option, what's great about that is, and we'll get into this when we're doing the multi-tenant side, or the automation side, is you can configure MySQL to do TLS authentication. So you can fire up Cert Manager, and part of your onboarding is creating the right certificate objects to be able to properly authenticate into MySQL. So now again, there are no static keys. Everything is dynamic. and then you let, of course, MySQL or you let Cert Manager take care of your certificate rotation. So that gives you a lot of flexibility that you don't really have with etcd. It also makes the backups so much easier because again, you're not dealing with etcd and you're not dealing with its shall we say um, voodoo like requirements backups. Um, so yeah, so we're gonna go ahead and once we get this set up, we're going to get MySQL set up in HA with Cert Manager for authentication. We'll use that as our backend for an HA vCluster. Just kind is it's taking its time.
Yeah, it's doing the multi, so.
Yeah, I'm going to while this is going, I'm going to do this off screen, but I'm going to go ahead and launch the same thing, and if it just happens to go faster, chapter 2 HGA.
Yeah, there you go. So I had to do the 3, because then of course it's deploying the HA proxy container.
Why is this? Oh, because it's capital. There we go. I was losing my mind. All right. So let's see which finishes first. If this one finishes first, I'll just drag it over. Um, yeah, I don't know if it's because my VMs are just running slow. Yeah. Okay, we're getting progress here.
It's pretty quick once that's deployed, at least.
Yeah. Well, hopefully I think a big part of it is Docker Hub has really changed and is really throttling containers. So anything that pulls directly from Docker Hub. Um,
What I've seen more and more, Mark, on some projects that use Kind as an example is Cilium does this. They actually, one of their commands is to cache it.
yeah. All right, let's see here. Kube control get pods. All right, so let's watch kube control get pods. We're gonna wait for the nodes to get up and running. This one actually is already going, so maybe we'll switch over here.
Mm-hmm.
Watch kube control get pods A. All right, let's see who gets there faster. I suspect my DigitalOcean is going to get there a little quicker because I've already got my Calico pods running.
Yeah, this is definitely slow.
Yeah, so we're going to go ahead. We'll just move this over here. That's fine. So this is almost to the point where we're ready to go ahead and see this working. Yep, we got our Calicos running. So we're just waiting for, once that's all good, we'll see that the Nginx controller is up and running. And we don't really need to, the original point of this demo was to be able to show HA access to the API server. We're talking more in this instance being able to run vCluster on a multi-node, a multi-node cluster. So there's the controller. So yeah, we're done, right? Yikes. So clear.
Is that the multi-node one, Mark?
Yeah.
Huh. I thought there'd be more on it.
Kube control get namespace, kube control get nodes.
Yeah, I was going to say, because the output from the multi-node usually shows you the worker nodes, having the 3 of them.
Oh, fine.
Nice claims to speed
Wow.
on that one.
Okay. Kind, delete,
If you do
and
the multi one, I list out the nodes so you know what nodes they are in the 172 range.
kind cluster, delete cluster.
Cluster, yeah. Now you can check your local machine. Probably done by now.
Yeah. No, this one I think just died.
Oh, wow.
All right. Let's try this again. Once more with
Okay.
feeling. So yeah, so this is going to take a hot second to get deployed again. But what we're going to do is once we get this deployed, we'll go ahead and deploy MySQL, and then we will show off deploying a multi-node vCluster. And the cool thing is like, it really isn't that much of a difference, right? Like that's a nice thing is that you've got one values YAML basically that manages what um, what you need to configure, um, and like that's it, right? And so that really, Loft really did a great job of engineering the configuration into a single file for a complex system. All right, so we got storage class.
Yeah, it's got the HA proxy deployed. Definitely
And
does
then
take
one,
more time because there's some more health checks behind the scenes. And
yeah. And then the last thing we'll cover after we show the HA cluster running, or the HAV cluster running, is going to be upgrading. And this is the thing that like is so amazing to me about vCluster upgrades is especially if you're using K3s, when you upgrade K3s, it upgrades the downstream data. So all you're doing is you upgrade the pod, and the pod goes, oh, I'm an upgrade. Let's run the upgrade script on the database to upgrade all the objects. And boom, you're done. All right.
so I'll
So,
call a note on this one just for everybody watching here, Mark. Right, so you see I fluke HA proxy. At the beginning, you might have saw that it said deploying load balancer. That's for the API server. But when you do a multi-node in kind, it doesn't include an HA proxy for the worker nodes. So that's what we create there is another HA proxy instance to go between the
there we
worker
go.
nodes.
All right. So we at least got the right one. So now we just need to pods and kube system. All right. So Calico's probably, yeah. So once these pods are all running, then Core DNS will be up and running. We'll be in good shape.
Real quick, Mark, do a Docker PS, if you wouldn't mind. Just kind of showing in here. You'll see that we have two HA proxies.
Yep.
That one with kindness obviously is the one that comes with kind, which does your API. And then the other one is just HA proxy because I was too lazy to name it anything else. It's just, it's there for the nodes for the load balancing, and it creates the config file and everything else that
Right.
lets that go.
Let's see here. He's running. We're getting there.
These are pretty big containers to pull in. It does take some time.
Yeah. I
And
wanted
it's three
to
different
get,
nodes too.
huh?
It's three nodes, so you're pulling
Yeah.
them all. And,
Well, and the other thing that I didn't get a chance to do that I wanted to was there are projects, or we looked at changing the configuration in kind to change Docker.io to uh, one of the pull through um, hashes out. Like Amazon's got one, Google's got one. but I didn't get a chance to look at it. I was on vacation last week in the Outer Banks, North Carolina, so I was getting some nice sea air, some salt air, and eating lots of ice cream.
And in 2 weeks, I'll be on vacation. Mark, so I'll be here for next week.
Nice,
And the week after, I'll be on my visiting the mouse and then cruising on the mouse ship.
nice. I had the most interesting conversation with my children yesterday about the difference between copyright law, patent law, and trademark law.
That's the kind of conversation you should always have with children.
Yeah, it's important part of raising children
And fair
is to
use.
make
Just
sure
throw
they
that in.
understand intellectual property laws. Well, so my kids both collect Pokemon. Now, I never was into Pokemon as a kid, but excuse me. So one of my son's friends was telling him that his Pokemon cards were fake, and my oldest son was telling my younger son, no, you got them out of a real pack. They can't be fake. And so they started that, well, they can't copyright every card. Well, no, actually, they do copyright every card. See that little C on there? Copyright is for content. Oh, well, how do they make sure that it's not, it's not, the wrong one? Well, that's trademark. Oh, and and then that got us to Disney, where my oldest son, allergies, love him. My oldest son has this thing that we bought off of Etsy. Really cute, baby Star Wars, like, you know, you can do it, kid, whatever. And we got it from him since he was an infant. And when our younger son came around about 2 years later, um, we couldn't do that anymore because the mouse had gone after all the grandmas in the Etsy stores for making unlicensed things. And so, the son was like, why did they do that? I said, well, because the mouse is kind of a greedy jerk. But he seems so nice. I'm like, yeah, wow, that's the face he shows everybody.
Still a business, without a
Still a
doubt.
business. All right. So I think we got all of our pods here. Our kube control, get pods and ingress nginx. Okay. So that's still going.
5 minutes. That should be up by now.
Telling you, man, it's
Oh yeah, it is
pulling
still.
stuff in from Docker. Okay, so that's going. So I'm gonna cheat here a little bit. Because remember, kids, eventual consistency is a lie. Do control get events and ingress nginx. All right. Pulled. Failed mount. Oh, no. 21 seconds. All right, so. Okay, so we're running. Yeah, don't need to worry about getting
Yeah,
that.
it will be.
So, do I have vCluster? I don't actually think I have vCluster installed on here. No. All right, so where am I? One downside to so chapter. Oh, you know what I'm going to do actually? Victor bin wget. I do have wget on here. All right. I'm going to pull in. If I can find it. Here we go. I'm going to pull in the older version of hmod plus x vCluster. Move vCluster to vCluster. Then export path. gets bin path vCluster version. Oh! Move vCluster into bin once more with feeling. Okay, cool. So we have vCluster running. All right, so now let's go ahead and move this over to here. All right, so let's go ahead and let's create our vCluster. So first thing we're going to do is deploy MySQL. So let's chapter 9. And I am on page 287 if you're following at home. Chapter 9 HA. So first thing I'm going to do is deploy MySQL. So this isn't doing anything crazy. We're not getting into how to set up a production viable MySQL, only to say that this is not it. There are a lot of great operators out there that will automate MySQL management for you. Now, we are an enterprise guide. We talk enterprise, and so here we are running our own MySQL. If you can't run your own MySQL and maybe you're forced to run, shall we say a non-open source database, you're out of luck, right? You're going to have to go with etcd because Kine, not kind, Kine, Kine, the project that allows K3s to run MySQL or Postgres or SQLite for Kubernetes does not support anything besides MySQL, Postgres, or SQLite. So it doesn't even support MariaDB. So if you are not in a position to be able to onboard your own databases, you're probably going to end up going with etcd. I like this approach personally, so that's the way. That's why I pushed it. But like I said, in an enterprise, we don't always have the control over systems we wish we had. You wouldn't know anything about that, Scott, would you?
Not at all.
No, not even a little.
Welcome to enterprise.
Yeah, knocking down them walls. So we're deploying Cert Manager. We're waiting for the Cert Manager pod to launch. It's almost as much fun as watching paint dry.
Yeah, definitely slower than it used to be.
Well, Cert Manager itself does take a while to get running. I don't know why. I've never known why, but it does take a while to get it up and running. I think, have we deployed MySQL yet? I don't think so. Yeah, so this is just getting Cert Manager up and running.
I'm usually impatient. I wind up spawning like 14 different windows so I can watch them. Like it helps, right? I'm just watching all the time.
So, oh, it does look like I eventually came up. So I'm going to go ahead and I'm on the right one, right? IP ADDR, grep 192. Yes. All right. So you know what? We're going to see who goes faster. Not that I really think that this VM is going to go faster. Nope, not GA, HA. Deploy MySQL. Let's see which one goes quicker. Although that does seem to have gone faster once the once Kind got up and running. So maybe I'll be surprised. It's kind of like they do this in baseball. I don't know if they do it in a lot of other sports, but they get the races, like here in DC, the president's race, or Teddy Lincoln. Yeah, see, look, so that's interesting.
Yeah.
The cloud hosted got Kind quicker, but the local hosted gets all our stuff running faster.
Yeah, much quicker. That's like a quarter of the waitings.
Yeah, well, I mean, we're
Actually,
still waiting
still.
for Cert Manager over here up in the cloud. Who am I using? DigitalOcean.
But
So we're waiting for MySQL to get up and running. Let's see, has Cert Manager even gotten? No, we're still waiting for Cert Manager over here. Oh, no, there we go. So Cert Manager got created. All right, so MySQL got created. And no, that's all right. We're going to go ahead and rerun this again. Although my API server does seem to be running kind of slow at this point. Okay, there we go. So it's come on, servers, you can do it. If you're out there, you want to say hello, please say hi. I'll go ahead and re-upgrade MySQL, realize it's running, and then go ahead and finish the last few steps. Generally, the scripts are safe to rerun. Although in this instance, we seem to be running into issues. All right, so kube control, get pods, and MySQL. Okay, let's see. Deploy MySQL. So we're getting here. So this is the thing, this is the last thing, which is just creating the database. Let's see if I can run it manually. Oh, it did run. Okay, I think it was just a warning. I mean, it's right. You shouldn't do this in production, but this isn't production. Okay. Show databases. All right, so we do have our database for vCluster. So what we did was we automated the creation of the database. We created the certificate. We created everything that you need to run a vCluster. And then now we can actually go ahead and we'll create the tenant namespace. Where am I? Yeah. Nope. I logged down my export. PS1 gets that. All right. Chapter 9. Multi-tenant. No. HA. Here we go. All right. So we deployed MySQL. So let's go ahead and create our vCluster tenant. So that created the namespace, and that created the role bindings needed so that vCluster could load the certificate information, and it also created a certificate, right? So if we look at get secrets and tenant one, we now have a certificate and key pair that we're going to be able to use to talk to, that vCluster is going to be able to use to talk to MySQL. Oops, so I'm going to go ahead and, right, yep. So this is at the bottom of page 287. So what we're doing here is we're launching our V10, our vCluster. So now if we do kube control get pod, well, give us a second. Let's look at vCluster tenant one. There we go. Nope, that's the wrong one. Less vCluster HA YAML. There we go. So here are the big differences. We now have this backing store, right, where we're telling it we're going to use a database. Our data source is going to be the database that we created for our tenant. And here are the keys being mounted in down here through the extra mounts. So the idea here is that there's going to be a database available that can connect to that vCluster has credentials for because it's using certificates. So we're not embedding any passwords or tokens into this values file. Because if you're ever in a situation where you're embedding secret information in a values file, you're doing it wrong. Like you need to go back and rethink how you're handling that. Let's see here. How are we doing on pods? Kube control, get pods, and tenant. Sure, if I go look at proc logs. Okay, so it's up and running. Let's see what control logs F and tenant one. It's probably going to complain about syncer. Right, so it's got two running. Out of curiosity. Yeah, this one's still waiting for the MySQL pod. Quest timed out. Wonder if I need to give this VM a little more horsepower before our next. Okay, so it's still going. It had to do a restart, so that's not a good sign. Control logs F and tenant one C vCluster. See if we get any logs here. Nope. Let's see if there's anything coming from the syncer. All right, so what's going on here? Something's going on. All right, so it's initializing. It's just taking a minute. Yeah, and we can even see that it's updating data. If we take a look at the MySQL database, see, are we okay? Here we go. So it's taking a hot second, but now we can see that core DNS is up and running. So we're in good shape. Everything's configured properly. And actually, no, we have a virtual cluster now. Everything's up and running. So the nice thing is that if we lose a node, right? We have another node waiting for us, or we want to run an upgrade. So we've now managed to automate or we haven't automated, but we've onboarded a vCluster with a database. Now again, I'm using K3s. I like K3s. If you're using etcd, you're going to need some kind of storage, right? That's able to move across your nodes. But that's outside this chapter. So yeah, we're in good shape now. So the last thing we're going to do, I know we're running a couple minutes late here, is we're going to upgrade our cluster. And so right now, if I do a kube control get nodes, or excuse me, I'm going to go ahead and vCluster connect vCluster list. Tenant one, tenant one. So I'm going to do a vCluster connect tenant one and tenant one. All right, so kube control get node. So all our nodes are running 1.29.5. So that was the previous version from when we published the book. Because when we published the book, we were on 1.30. I think 33 is set to come out next couple of weeks. But we want to upgrade this, right? Here's the beauty of vCluster. The way that we upgrade it, and can actually show here. So I'm on page 288. So this is in the host. We can actually see. Whoa, that was weird. Oh, ha! Logged out again. You guys didn't see that though. All right, SSH port PS1 gets okay. vCluster disconnect. Let's try this again, shall we? All right. There isn't? Kube control, get pods, and tenant one. Oh, because it's deployment. So since we've written the book, this particular exercise doesn't work anymore, which isn't that big of a deal. Kube control, get pod, and tenant one, O, JSON. All right, so this will tell us the node version. So before I did a kube control get nodes, and that showed us that everything was 129. Here we're getting it from the host cluster to see. So if we want to go ahead and do an upgrade, that is really, really simple. We are going to simply update our cluster. So if I go to chapter 9, HA, so this is what we used originally. And we specified here we wanted to use 1.29.5 because we wanted something that we could upgrade. So now we're going to use the upgrade file. And the only difference between these files is we changed what tag we want to use for K3s. So now we're going to go ahead and do an upgrade. Okay. And to rock and roll. So it's just doing a Helm upgrade, right? So if we do a watch kube control, get pods and tenant one, it's rolling out a new version of the deployment in a way that's HA, right? Because the old one is still going too. So you've got an HA rollout, and it's going to take a few minutes, but and we don't have to stare at the paint dry. We know it's going to take a little while. But the nice thing is as the pod starts, it sees that the data in the database has changed, needs to get upgraded, and it's just going to upgrade itself, right? It's self-upgrading. So it's not like you're running a special command or, it's not like if you've ever done a kubeadm upgrade where, first you got backup kubeadm, although you should be backing up your kind database. Don't get me wrong. But first you got to back up the database, excuse me, etcd. Then you got to do a check. Then you got to go ahead and upgrade the API server. And you got to do that on each individual node. Here, you say, okay, I'm going to go to a new container. And as the container launches, it says, well, okay, this is a 29.5 database. We're going to upgrade to a 30 database for you. And that's it, right? There's not a whole heck of a lot going on in there. And we can see now that we're actually running for one of them. And so I assume once this one gets running, assuming there are no puffs of smoke coming out of my lab over there. Once that second one gets running, it'll kill off the old one. So we now have 3 running Kubernetes API servers. And so this last one will likely get killed here in a moment. Just waiting on, because you can see here, it's a different deployment rollout, right? These two are both associated with this rollout. This is the old one, so we're just waiting for it to go to the big bit bucket in the sky.
And this is really
there
fast.
we go. It's terminating.
This is usually quicker, Mark, than I've seen. Like, real production type clusters. Yeah.
So let's go ahead and let's reconnect. Here we go. Right, so kube control, get nodes. So now my APIs, oops. Oh, because those are workers, that's why. And I did again.
I do that all the time.
Yeah, I keep forgetting that Control D doesn't get you out of. All right. vCluster disconnect. Right. So now I'm out of vCluster. Kube control get pods and tenant 1. Let's go ahead and grab one of these. No. Here we go. And there we go. So we are now running, our API servers are on 1.30. So we covered 3 big topics, right? We covered how a vCluster is going to connect to a remote service like Vault. We covered how to deploy an HA using MySQL and upgrading. So the finale, the grand finale of Chapter 9 next week is going to be automating all this, right? So that we're not, we're not running these scripts manually. Because I don't know about you, but personally, I'm kind of lazy. I don't like running things.
No, doesn't exactly scale.
Yeah, exactly. So same bat time next week, same bat channel, and you're going to wrap up Chapter 9 in vCluster and pull this all together. So thank you, everyone, for joining. If you are enjoying the book, please leave us a review on Amazon, please, I beg. I don't beg for much in life, but I do beg for reviews. And have a great rest of your day.
Thank you, everybody.
Where's my mouse? There it is. End stream.